And now we are moving to, thank you very much, Hugo. We're moving to the next speaker. Our next speaker is José Luis IZKARA, a PhD in information technologies and communications engineer. He's a project manager in the Energy, Climate and Urban Transitions Unit of TECNALIA, working at Labian TECNALIA since 2000 and currently working in the area of urban transformation. The main interests of José Luis are GIS, urban digital twin, advanced visualization, and he has been participating in many research projects at the European and national level. Some of the most relevant for the project topic are urbanage, smart in city, shelter, and impactor. He has several publications in journals and Congress proceedings in digital tools and geospatial urban models. More than 20 of them are indexed in the Scopus. He has also experience as professor of computer science at Deusto University from 2021 to actually, and at the School of Engineering of Bilbao. He's the co-director of 2 PhD theses, so he will provide us also, as Antonio did, this part of the research on the development of digital twin. He has been external reviewer of different journals such as the TIAS Commission of the Spanish Innovation Ministry. So José Luis will present us his talk about digital twins for infrastructures and urban ecosystem, 2 pilots in Spain. José Luis, are you with us?
Yes, here it is. Can you hear me?
Yes, I see you. So, very well. So the floor is yours.
Okay, so I will share my screen. Okay. Okay, so thanks for the invitation first and for the presentation, of course. And I just want to thanks and say good afternoon to everyone. Okay, so the title of the presentation was already presented, and I just want to highlight and to show the relevance of the data. Just a short introduction about the relevance of the data for the smart city. It has been also mentioned in the previous talks, and I think it's well known by everyone, but just a few words that it's a shared opinion that data-driven innovation is a key pillar to deliver new forms of development in this new century. Also, I think it's also important to consider that smart cities are considered as a suitable place to exploit data to make networks and services more efficient through the use of ICT for the benefit of the inhabitants of the business. Data must be seen as a common good, not as a product to purchase. It's key to fulfill develop the intelligence around the smart city. The administrators are betting on the creation of value from the reuse of the data, and there are a lot of initiatives at different levels, at the regional, national, or European level, showing the importance of the open data. But being open does not mean that will not be any business around the exploration of the data in the context of the city. In fact, new or agents and relevant players are well positioning in this area, in the data, in the business, in the data business. And those companies in different fields, utilities, big IT companies, research centers and universities, We can see here just an example of some of them. But what is needed is to identify which are the key elements or the key aspects which allows to exploit the data into the built environment. The data itself, as we said, should be considered as open as possible, but we need to exploit the data or identify the relevant aspects to exploit this data. And we think that there are a lot, but we identify three that are key. First is the enhancement of the data with the contextualization through geospatial information systems. The geospatial context of the data is first one. Second one is the integration of data from different domains and from different agents, the integration. So not to have the data isolated, but the integration from different domains and from different users in order to extract knowledge and to facilitate decision making. And the third one is the visualization and the interaction with the data, and to innovate in how to exploit the data in the sense of visualization and interaction for better understanding, not only for technical people, but for being able to all kind of users. In this context, in the context of extracting value to the data, the concept of digital twin is one of the key instruments, at least at the urban level. A digital twin, it's considered, or it's defined as a virtual replica of the main elements of the city and its processes, which are able to, which enable to analyze, model, simulate, and predict scenarios or develop hypotheses to support better decision making in urban planning and infrastructure management. From TECNALIA, the concept of digital twin is based on modeling the city and its processes through this digital twin based on 4-layer models. From the bottom to the top, we identify as elements, as relevant elements, the technical infrastructure, the physical infrastructure of the city, the urban planning, and the citizen. And the connection between the 4 layers will allow to better understand, to interact, to simulate, and predict better into this, into the city. One example of this concept of digital twin is the implementation of the IZKARA digital twin. IZKARA is a company which provides information about the location of the technical infrastructure, integrating data from different utilities. The IZKARA digital twin is not a digital twin of the utility, is not a digital twin, in this case will be a digital twin used for the network management. Is not this, is not also a digital twin of the city, which is necessary or which can be used for the city management. Is something in the middle between the utility and the city, which allows connecting elements from both sides, from the utilities and from the city, and allow to develop added value services based on this connection. The implementation of the digital twin is shown in this, of the IZKARA digital twin is shown in this figure. We use different data sources, combining data from the different utilities and from the buildings. We create a semantic 3D model which represent the urban and utility network based on the CityGML standard and the utility network application domain extensions. And with this semantic model, we provide access to the information in order to develop smart city services. In this case, we have implemented 2 specific services for 2 areas on 2 Spanish cities, one in Bilbao for sustainability and the other one in Zaragoza for trade monitoring. As a result, we have implemented the INCOLAN digital twin, which is a semantic 3D model of the network and the network elements with associated information. In this information, we include structural, static information, and also dynamic information collected by sensors. And the digital twin is visualized visualized through a 3D interactive visualization. Then the second result is the sustainability city viewer implemented in one specific area of the city of Bilbao. In this viewer, we integrate the network and the urban elements. Urban elements which include buildings, green areas, pedestrian areas, and so on. And then we have calculated sustainability indicators, which has been done combining different data sources from the utilities and from the municipality. And the third result is the economic activity viewer in the city of Zaragoza, which includes information at different scales, at the building, at the block, and at the aggregated area. And we are combining data from energy consumption and car payment in order to identify the differences of the economic activity before and after the COVID pandemic. So in this case, the key elements of the INCOLAN digital twins is the enhancement of the network and the consumption data for smart city services. We have to highlight the importance or the relevance of the georeferenced data, and also the contextualization by combining public and private information, integrating different techniques and different technologies like GIS, data analytics, or IoT, and the innovative interaction and visualization techniques for better understandings, including 3D models and a control panel. We identify by the end of the problem that arise different opportunities within the framework of the smart city by this combination of the utility data and the urban data. And for example, combination in the maintenance of network elements, minimization of incidents and improvement of work coordination, synergies for the development of work intention, risk for climate change in infrastructures, the city and the citizens, possible barriers and joint actions, monitoring and support for local trade, and energy transition and urban regeneration, for example. This is just a screenshot of the viewer, and here is the link of a small video that can be shown in order to better understand how is this digital twin. And just this was all. Thank you for the attention.
Thank you very much, José Luis. We are, with your contribution, I think that we can start wrapping up, and I very much enjoyed the way in which we structure this better understanding, better interact, better simulate, and better predict, which is what the use that we get, the public servants will get from the digital twin in these 3 layers, from the natural layer, from the social layer to the technology. In which processes have to be modeled as well as relevant for that. You also told us this bridge between the utility, digital twin, and the city, digital twin. And well, with that, we are looking forward definitely to try to use those data for example, the GIS data that you were implemented as well. And probably what my first question that arises after your presentation is regarding the role that artificial intelligence can have in these decisions. Again, what we are having here is an element that allow us to have a clear interaction, but I understand with the and definitely simulation, but when we are going to the prediction stage, I understand that here it comes a moment of new algorithms to provide us with this predictive approach. Did you try that in your implementation of the digital twin, or this is an area of open research in for you and your colleagues in TECNALIA?
Yeah, thank you very much for the question. This is, I think, these are the different levels of the digital twin. We consider the first level in the digital twin just the digital twin as a semantic model. The integration between the model with the dynamic data, this is a step forward. This is a new challenge in the digital twin, a new level. This is the level where we are now, more or less. And the next level is the connection with the artificial intelligence. We did a very small example, just with the connection between the electrical utility with the buildings that are connected to each of the elements. But in fact, this is the real challenge for the near future in our digital twin.
Right. Thank you very much. Now we have a set of very good examples that can have been applied also in different perspectives and different points of view. Now I would like